Hello everyone. In this video, we are going to discuss about chemical sensors. That is what is meant by chemical sensor. Then components of a chemical sensor, types of chemical sensors, and certain parameters used to characterize the performance of a chemical sensor. So, what is meant by chemical sensor? Then components of a chemical sensor, types of a chemical sensor, and certain performance characteristics. So, chemical sensors, what is meant by a chemical sensor? Chemical sensors are small devices that convert chemical information like concentration, activity, partial pressure of a substance into a measurable signal. Okay, so that chemical information which related to a species, that is concentration, activity, partial pressure, and converts a chemical sensor convert that chemical information into a measurable signal. And generally, the magnitude of a signal is directly proportional to the concentration of the analyte. So, by measuring the strength of that signal, it will give an idea about the concentration or chemical information, whatever it is. It will provide a chemical information of that particular solution. The major component which is present in a chemical sensor is receptor and transducer. So the major component which is present in a sensor is receptor and a transducer. Okay. Suppose consider a sample which consists of different chemical species. So the part which of a sensor which is interact with the sample is the receptor part. Okay, so among the two different parts, the receptor part interacts with the analyte in the sample and produces a change in property that can be measured. Okay, so receptor interacts with the analyte and it undergoes some changes in the property of that receptor. Then what the transducer contains the electronic components. Okay, receptor interacts with the sample and the transducer it contains the electronic components that detects and measures the change in property produced in the receptor and converts that change in property into a measurable signal. Okay, so once again, receptor is a recognition element here. It is the component that comes into physical contact with the analyte and interacts with it. The interaction may be chemical interaction, biochemical interaction, or physical processes like adsorption, ion exchange, etc. Okay, so the receptor part interacts chemically, biochemically, or some physical processes like adsorption, ion exchange. It can provide or it interacts with the analyte and changes some physical properties or change measurable changes occur. The changes like absorbance may change, refractive index of a particular material can change. Material that is which is receptor component. The property is related to the receptor component. The receptor may undergo change in absorbance, its absorbance, or refractive index may change, conductivity change, temperature, mass, electrochemical properties. So, by the interaction with the sample, it undergoes some physical or measurable changes like absorbance change, refractive index change, then conductivity, temperature, mass, or electrochemical performance. So, due to the interaction between the analyte and the receptor. Okay, these much of changes occur. Then what the transducer did? The transducer detects and measures the changes in the property produced in the receptor. Okay, these many changes are produced in the receptor by the interaction with the analyte. So transducer detects that changes and converts them into a corresponding chemical information or measurable signal or chemical or electrical information. That electrical information is nothing but the signal. Okay. This electrical signal is then amplified using an amplifier. See, here this amplifier A indicates the amplifier part. So the electrical signal which is produced by the transducer is then amplified by an amplifier and may be used to trigger an audible alarm and or an actuator or maybe some data presented on the screen. Okay, which can be obtained from the transducer and provide some information to us. Okay, this is the components of a sensor. Then next part is types of chemical sensors. Okay, what are the types of sensors which is present? On the basis of the transduction signals, different types of sensors are there. First recognition molecule, then sample contains different chemical species which interact with the transducer part, and it provides some changes, right? Okay, that changes may be electrical, then maybe optical changes, then some produces mass, change in mass, and also some temperature. If it produces electrochemical changes, that sensors are called electrochemical sensors. Suppose the sample interact with the receptor, okay, receptor, then it produces some optical changes, then that type of sensors are called optical sensors. For example, photocolorimetric sensor, it can change the property of a receptor or property of a particular solution by the absorbance value, right? So it's called a photocolorimetric sensor, or it's a part of optical sensor. It produces changes in optical properties. Then some certain sensors change in the mass. So mass sensitive sensors are there, or some thermal sensors also there. These are different types of chemical sensors. So you know what is mean by a sensor is, or chemical, especially chemical sensor is, then what are the components of a chemical sensor, then types of chemical sensor on the basis of transduction signal. Or transduction means that conversion, one data into another data, or chemical properties into a signal. Okay, so on the basis of transduction signal, if it is electrochemical or thermal, mass, then again optical. Okay, then next coming to the performance characteristics, means there are certain parameters which is used to characterize the performance of a chemical sensors. The first parameter is sensitivity. Okay, sensitivity means the change in measurement signal per unit concentration of the analyte. For example, if small change or unit change in the concentration, it can produce large signal variations. For example, certain concentration, 0.01 milligram concentration itself can produce large absorbance variation, right? So that type of sensors are called very sensitive sensors. Small change in concentration itself produce large measurable signal. So that type of sensors are called sensitive sensors. Okay, greater the slope, better is the sensitivity. If we plot the calibration graph, if in the calibration graph that slope of a calibration graph is very large slope, then that type of sensors are called sensitive sensor. So this is sensitivity. Then the next parameter is selectivity. Okay, first a chemical sensor is highly sensitive, and then it should be very selective. Especially there is another term in addition to the selectivity, the specificity also. If a sensor responds to only one specific element, that type of sensors are called very specific sensor. Suppose it reacts only to a group of analytes only, that type of sensors are called selective sensors. So selectivity and specificity, which are more related terms, if it is specifically react or sense only one element, a single element, then that type of sensor is called a specific sensor, or specificity is very high. If it react only with a group of analytes or sense a group of analytes only, then it is called a selectivity. More selectivity is very desirable property of a chemical sensor. Okay, so irrespective of the presence of other species in the sample, the sensor shows selective response. Then the third parameter, so sensitivity and selectivity is over. Then the third parameter is detection limit. Detection limit is the lowest concentration value of the analyte which can be detected by a sensor. Then the fourth parameter is dynamic range. Dynamic range is the concentration range between the detection limit and the upper limiting concentration. Okay, so this is the concentration range in which a sensor can react, or sensor can sense, or it give an ideal linear response. For example, in a photocolorimetry, if concentration is very high, then it will not give a linear relationship between the concentration and the absorbance value. So its linearity may vary in the high concentration. So concentration range is very, or dynamic range is very narrow in the case of photocolorimetry. For some sensors, the dynamic range is very wide. Okay, then the next part is resolution. A resolution is the lowest concentration difference which can be distinguished when the composition varied continuously. Okay, If in a particular sensor the concentration we have to sense so a system in which the concentration is continuously varying, suppose consider that type of situation, then what is the lowest concentration difference which can be distinguished, which is called the resolution. Okay, then response time means the time required to respond from zero concentration to a step change in concentration. Okay, if vary from one concentration to second concentration, what is the time required to respond? This is called a response time. Then the hysteresis means the maximum difference in output when the value is approached with an increasing and a decreasing trend. Suppose we can change from zero concentration to higher concentration, or we can measure the signal by varying zero concentration to high concentration, or we can change or we can measure the signal by decreasing the concentration, right? So, what is the change in output if we decrease or increase? Measure the change in measure the signal both way, by increasing the concentration and by decreasing the concentration. If any difference is there, then this is not hysteresis, perfect hysteresis. Or then if there is no change, then it will a perfect hysteresis. Okay, so what is the maximum difference? What is the maximum difference in output? This is called hysteresis. Then stability means the ability of a sensor to maintain its performance for a certain period of time. So it should be very stable for a period of time. Then the life cycle is the length of time over which a sensor will operate. These are the some of the characteristics of a sensor which is used to characterize or a particular chemical sensor. Next topic is electrochemical transducers. We already know that on the basis of transduction signal, the sensors can be divided into electrochemical transducers, optical transducers, thermal transducers, mass sensitive transducers, etc. Right? So, in electrochemical sensors, it operates by reacting with the analyte of interest and producing an electrical signal proportional to its concentration. If the on due to the interaction with the analyte and the receptor part, if any change in the electrochemical properties and produces an electrical signal by the transducer, then it is called electrochemical transducers. So the there are different types of electrochemical transducers also. Okay, on the basis of what type of parameter or electrochemical properties changing in it. Suppose the electrical signals may be change in current or voltage or impedance. Okay, so electrochemical transducers means by the interaction with the analyte, it produces an electrical change, and on the basis of what type of electrical change, suppose it is current, voltage or impedance, then again electrochemical transducers or thereby electrochemical sensors are classified into potentiometric transducers or potentiometric sensors, and voltammetric or amperometric sensors, then conductometric sensors. In potentiometric sensors, the sensor measures its potential at zero current, or its cell potential at zero current is measured in potentiometric transducers. In voltammetry or amperometric transducers, an oxidizing potential is applied between the cell electrodes and the cell current is measured. In potentiometry, potential is measured. In voltammetry or amperometry, the cell current is measured. And finally, in the conductometry, where the conductance, that is reciprocal of resistance, is measured by an alternating current bridge method. So these are the three electrochemical transducers and three types of electrochemical sensors. Then what is meant by this potentiometric sensors? So there are three types of electrochemical sensors on the basis of the parameters, whether it is voltage, current or resistance. The electrochemical transducers are classified into three. So first type is potentiometric sensors and its working principle. So potentiometric transducers involves the measurement of EMF of an electrochemical cell at equilibrium. So you know that EMF is defined as the maximum difference in potential between the two electrodes of the cell when the cell current is zero. So Potentiometric transducers involves the measurement of EMF. Okay. So, in an electrochemical cell, what are the components of an electrochemical cell? Okay, you already studied in previous chapters. So, electrochemical cell is designed for this analytical applications. Also consist of two electrodes. So, one electrode is called reference electrode, and the another one is called working electrode. See this figure. The left side, which is present here, is reference electrode, and then the right side, the whole system, is called a working electrode or indicator electrode. Here the indicator electrode, which responds selectively to the analyte ions in a solution. Okay, this indicator electrode, here it is called ion selective electrode. The whole part is called ion selective electrode. That electrode part, right side, the right side, which shows an electrode which is called working electrode or indicator electrode. In this potentiometric sensors, this electrode is called, specifically called, ion selective electrode. Okay, then the measured EMF, by connecting these two electrodes, an EMF, a potential difference is obtained. Here in this case, the reference electrode is generally silver chloride potassium chloride electrode, or calomel electrode also can be used. And ion selective electrode and the components of ion selective electrodes we will discuss later. Then next, what is the EMF? The E cell is equal to E cathode minus E anode. That we already know that, right? And one of the electrode is reference. And already we know that the reference electrode is calomel or silver chloride potassium chloride electrode, and its potential already is constant. Its potential is constant. And the working electrode shows different potentials at a different concentration of the analyte solution. Actually, here we did not use the concentration term, and the term used here is activity. So the potential, already the reference electrode potential is constant, so the potential obtained from the cell is different on the basis of the activity of the analyte solution. Analyte means here the solution whose concentration we are going to determine. So the potential obtained from this potentiometric sensor, which indicate the concentration, exactly saying the activity of the analyte solution. And the E0 E value, the cell potential which is related to the activity by the equation, Nernst equation, E is equal to E0 plus 2.303 RT divided by NF log A. Log A. Here A is the activity of the analyte ion. So E is equal to E0. Actually, it is E0 minus 2.303 RT by NF log 1 by A. So 1 by A will it changes to log A, then there is a negative sign. So negative and negative, it will become plus. So E is equal to, the Nernst equation for potentiometric sensors is E is equal to E0 plus 2.303 RT by NF log A. Okay, and what is meant by this activity? Activity means number of active ions in a solution is called activity of that particular solution. We can use a term A for that activity. Suppose A is equal to C into F. If C is the concentration of that solution and F is the activity coefficient of the ionic species. Okay, so activity of a solution is equal to C into F, where C is the concentration and F is the activity coefficient. Here, for dilute solutions, the activity is equal to its concentration. Activity is equal to its concentration for dilute solution. For concentrated solution, it will not be like that. Okay, what is the concept of this activity is that for dilute solutions, all the electrolytes are completely dissociated. For dilute and strong electrolytes, and also in the case of strong electrolyte, in dilute solutions, its electrolyte is completely dissociated. So what happened, the all ions are, which is available for the concentration also, all the ions are there. So the solution is called an ideal solution. Okay, ideal means completely dissociated. Its concentration and activity is the same. All the electrolytes are dissociated, so ions are obtained for the concentration. But in the case of strong electrolyte, or not strong, very concentrated electrolyte, then what happened? Its dissociation is not complete, so the active ions are not the concentration. So concentration is and concentration and activity is different for concentrated solution, but it is same for dilute solution. So in order to adjust the activity, or in order to fix the analyte solution so that the activity and concentration are equal, we need to add an electrolyte, an inert electrolyte, to the analyte solution in during the analysis of potentiometric sensing. And the electrolyte here we used is called ionic strength adjustment buffer, or ISAB. The commonly used ISABs are potassium chloride, sodium nitrate, NaOH, and acetate buffers, etc. Okay, this is here. What is the relation between activity and concentration? Activity is equal to activity is equal to the concentration when the solutions are in dilute. If it is not dilute, activity and concentration are different. So in order to adjust, or in order to fix the analyte concentration and activity is equal, we need to add some ionic strength adjustment buffer. The most commonly used ionic strength adjustment buffers are potassium chloride, sodium nitrate, NaOH, and acetate buffer solutions, etc.